Yeah, let's talk about this tool. It's open source. You can start using it today. A little bit about me, just before we get into it. So currently I work at R2C. This is our obligatory Zoom company photo. So we're a San Francisco-based startup, also working on improving security for various people around the world. And before this, I was at NCC Group. And I think one of the reasons why I actually joined R2C is because there was this sort of missing hole in static analysis tooling that I really wanted to exist. And I actually started building it on my own before realizing it was a huge amount of work and sort of too much for one person. And I stumbled across R2C actually in a happy coincidence. And that led to me joining. Before that, I was an indentured servant, grad student at UC Davis. Feel free to say hi on Twitter. And I also have a newsletter that you can check out if you want. So I'm going to talk a little bit about some high-level Semgrep background. Then we'll get into some live demoing where we'll sort of write some custom patterns together. Then I'll talk a little bit about some of the ecosystem around it, sort of the registry of rules and some integrations if you want to hook it up into CI. And then we'll talk a little bit more about Semgrep internals, because I think you all might have some interesting questions about that. So there's a lot to cover, so we might go a bit quick. So feel free to stop me whenever if you have questions, or we can just have questions at the end, whatever you prefer. So sort of the TLDR is it's a very customizable, lightweight, and open source static analysis tool for finding bugs or enforcing code standards. So Semgrep actually has a pretty long history. It was originally called Sgrep, and it was created at Facebook by Yoann Podolou, who was Facebook's first program analysis hire. So if you go on GitHub, it's Facebook archive/pif, which was actually used to enforce around 1,000 secure coding patterns within Facebook. So even before Facebook, it has its sort of intellectual origins in the tool Coccinelle, which, if you're not familiar, is sort of a tool from academia, INRIA, which I believe was used to file maybe over hundreds, perhaps 1,000 patches to the Linux kernel. So there's actually this long sort of history behind Semgrep, even though we've been sort of focusing on it more recently. OK, so let's cut to the chase. Why is it nice for security consultants or security researchers? It's open source. It's on GitHub. It's LGPL. Use it offline on whatever client source code you want. One thing that was very annoying when I was a consultant is that all of these fancy program analysis tools largely had very restrictive licensing. It supports many languages just out of the box. So Golang, Java, Python, JavaScript, Typescript, Ruby, C only a little bit, PHP a little bit, and many other languages we're constantly adding. You get a bunch of rules out of the box for all these languages. It does not require buildable source code. And we'll talk a little bit more about this in a second. But I think the biggest differentiator from Semgrep from other tools is that you don't need to learn this separate sort of painful domain-specific language where you're spending a lot of time like, OK, how do I even use this in the first place? Basically, if you're writing code to target, say, Python code, you're writing a pattern that basically looks like Python, and the same for Java and Golang and so forth. So I think that's really the key differentiator. So why is it nice for Appsec engineers and developers? Again, by being sort of easy to write. The goal is to make, if you have, say, coding standards, either on a wiki or in your brain or in code, basically anything you want to find and continuously enforce in CI, for example, like Travis GitLab runners or GitHub Actions, the goal is just how can we make that as easy and trivial as possible? Not if you're a program analysis expert, not if you're a security expert, but just like any developer, anyone who can write code, let's make that as easy as possible. So to sort of put Semgrep in your mental model for where is it on the static analysis spectrum, this is a figure from Benjamin's Instagram blog post that I think is nice. So on the left-hand side, we have these very easy, simple approaches like regexes using like grep or ripgrep. And then on the right-hand side, we have your sort of traditional SAST or whole program analysis where you're doing control and data flow across many files. Semgrep is basically in the middle. So we're trying to get these best of both worlds. We'll talk about that more in a second. So our worldview as a company, and thus we're sort of building into Semgrep, is the following. And this causes us to make certain trade-offs. So I thought Alessandro's points in the last talk about there's just different approaches and what are the trade-offs. So I think that's a good way to look at it, because ultimately you can't have everything and you sort of have to make assumptions and trade-offs. And so here's the ones that we're making. So one is we believe speed is very important. So we want to be able to scan even very large code bases in like minutes, not hours or days. We believe false negatives, it's better to have those than false positives. So we are working with many Appsec teams at a variety of companies, and they're just deluged by things that don't matter. And many companies are making the trade-off that's like, okay, like if I see something from your tool, I want it to be right at the expense of false negatives. Again, ease of use is very important. We think that there's huge value in organization-specific and even code-base-specific checks. And because of that, we want to really heavily prioritize first-time user experience. So we're not optimizing for like, you have a PhD in static analysis or you're a program analysis expert. We want people who's like, Alice, average dev, or John Doe, average Python programmer. We want to get them up and efficient and productive as fast as possible. And we actually have, I think there's things we can do better, but we actually have done a pretty good job at that so far. We see people who have like never used Semgrep before write simple custom patterns in like 30 minutes or half an hour from being, half an hour to an hour of being exposed to the tool and writing something meaningfully complex in maybe like a day or so. So I think more room to grow here, but pretty good, I think. And sort of philosophically about security, we believe the path forward for like truly scaling security in an organization, and we see this at companies like Google, Facebook, Microsoft, Netflix, Dropbox, and many others, that really enforcing this paved road or secure defaults is more important and higher in effectiveness than like trying to find every bug and sort of doing a whack-a-mole. Okay, so because of these because of these assumptions, we have certain design decisions. These aren't fundamentally will never change, but this is as it is today. So Semgrep currently focuses on sort of a single file and localized analysis because interprocedural data flow analysis is slow and imprecise in general. But this localized analysis usually is good enough for enforcing secure defaults and finding sort of straightforward, obvious bugs. And also, this allows us to not require buildable source and makes us very fast. And also, we want rules that look like source code. So this is nice for new users, but it isn't necessarily like a Turing-complete data log-esque language like CodeQL that can express any possible code pattern. Okay, so that's enough words. Let's demo. So first, we'll just do some sort of basic, what are the primitives in Semgrep, then we'll talk about some of the advanced features. Okay, so this is simplest possible case. Let's say there's some dangerous function that we want to find. How would we find that? So again, Semgrep is on GitHub, so feel free to check it out. This is the Semgrep Live editor, which is basically so you don't have to install anything. You can just write patterns in here, match it against code here, and then you'll see the results on the right-hand side. So there's no magic here. It's just like calling Semgrep in Docker in the background. So let's say we want to find every call to exec. How would we do that? So there's basically two abstractions that Semgrep provides on top of the programming language that you're looking at. One of them is the ellipsis operator, or ... So this means find all calls to exec with 0 or more arguments, and I don't care what they are. So if we were to run that, we can see we are able to find this call, so hard-coded string literal, or some variable, some exec. This isn't actually called exec. It's a different function. There could be white space here, or it could be on across multiple lines. And a common cause of false positives is like you're in, say, a comment or a string literal. We do not find those. But Semgrep has some intelligence baked into it as well. It's not just sort of like a direct AST matcher. So we see here that exec is locally aliased as safe function, and then we see its safe function being used here. So we are still correctly flagging that because it is actually calling exec. But note that our pattern is naive to the fact that something complex like that could happen. All we did is say, this is my intention, and then Semgrep added some sort of intelligence in the background to just do the right thing without us needing to know. And sort of philosophically, that's where what we're trying to do with the tool is be like, okay, let's abstract away some of the complexity of how to do what you mean and just do that. So that's one thing. Let's look at another example. So here, let's find a simple cross-site scripting in an example Express.js web application. But this is really sort of like a generic example of how user input comes in here and then eventually goes somewhere dangerous. So here we can see we're registering a route. We are getting a query parameter, and then we are just directly writing it to the response object. So because we're not filtering or processing the query parameter anyway, this is potentially cross-site scripting. So how would we find this? So one nice thing about Semgrep patterns being basically like the source code you're targeting, we can actually just copy in the code we want to find into the pattern bar, and then sort of abstract it away until it finds more generally what we want. So another helpful thing is if you want to match any string and you don't necessarily know what the string is, because here it could be any path, we don't care. You can just do, again, ... inside of it, and this will match any string. And then so the second thing, the second helpful abstraction that Semgrep provides is meta variables. So you can think of them like capture groups in regular expressions where you're like, I don't know what the value of this is ahead of time, but I want to match it. So here, the query parameter in other code might not be name, but we want to find something. So we can change this from a concrete value to a meta variable by giving it a $sign and then some identifier, say param. And then this variable, we don't know what the name of it is ahead of time. So like maybe we'll just say var, and then we'll pass it here. So basically, sort of what this is saying is, OK, we're getting something from a query parameter. We're assigning it to some variable, and then we're sending it out. OK, so if we run this, we can see that we basically matched this code. If we were to say, change this variable to something else, maybe instead of name, let's call it var, whatever, we can see that this still works. But it's still, we're being a bit perhaps too precise, right? So there could be additional statements between these two statements. They might not be one after the other. And also, maybe it's not just this variable being passed. There may be other stuff. So how can we make this a bit more generic? So the ellipsis operator can be 0 or more arguments or 0 or more statements. So we can add one in there. And then also there's this additional deep expression matcher operator that we can basically say, like, argument to write, somehow in that expression, this variable is included. So it could be just that. It could be a concatenation with a string literal or something else. So with this change, awkward lag. Well, what we're going to see is that we're still matching here, even though that it's not just this. And if we wanted to say, like, oh, maybe there's something that happens after that, we can see that that would be matched as well. It's just as long as this variable somewhere in there, it'll match. OK, so let's do one more example together, and then I'll just blow through a couple of features just to give you an idea of the expressive power. So far, we've looked at some security-related examples, but let's say there's business logic that we would like to enforce or find. So when doing pen tests, I found pretty much every application has something where, like, in this app, this behavior is a bug. Either like foo must be called before bar, or the order of these matters, or if this isn't called, it's a problem. So hypothetically, let's say that there's a financial trading application where you need to call verify transaction before make transaction because verify does some sort of it vets the state of the transaction object, and it makes sure that it's properly like the values are within bounds or something like that. So let's say we have some test cases here. So this function is OK because verify is called before make. This function is bad because it calls only make, and the transaction is not verified. If the functions are called in the wrong order, that's bad. Just verify is OK. There could be other statements in there, whatever. So OK. So sometimes you want to find not just a specific pattern, but like a combination of things. You might want to say this must be true and this must be true, or this or that, or this but not that. So Semgrep allows you to do like a Boolean composition of patterns. So let's look at how that might work. Conceptually, what we want to do is say, let's find every function that calls make transaction inside it. And then let's filter out the cases in which verify is called first, because then we know that it's safe. So let's do our handy dandy copy and paste the pattern. OK, so we don't necessarily care about the return type. So let's make that a meta variable. We don't know what the function name might be. So let's make that a meta variable too. We don't care about the arguments. Say, some statements can happen. And then at some point, we call make transaction. Just say arguments can be anything. And then sometime after, there's more statements. So basically, this is finding every function that is calling make transaction inside of it. And we can see that that's the case. So now in order to find like which of these are actually business logic bugs, we want to find the places that call make transaction, but verify is not called first. So we can say, this is a subset of the things that Semgrep can do, but these are just sort of the simple ones. So we could say, find this or that, or this is the scope, this is inside this other thing, but here we want to say and is not. So what we're going to say is filter out any function that has 1, 0, or more statements, calls verify transaction, and then later calls make transaction. So find everything that calls make transaction, and then filter out the cases that call verify first. So let's see what happens here. So this case is OK, because verify is called first. This is bad, because make transaction is only the thing that's called. Here we can see the order is wrong. Here we can see there's other statements in the middle, but the order is wrong. Here the order is correct. But this last example is interesting because the transaction that's verified is actually not the same one that is made. So this is probably also something that we would like to catch as a bug. So this is a false negative. So the way that we can find it is by, instead of saying, I don't care what these arguments are, we could use a meta variable to say, oh, match the transaction object that's passed in. And by using the same meta variable here, like in the previous XSS example, we are enforcing that those two arguments are the same. So if we do that, we are now correctly flagging this case because other is not T. So the sort of high-level takeaway here is we had an idea of some business logic flaw we wanted to find. We codified that in like 3 minutes in like 9 lines of code. And now we can roll this out in CI to catch it whenever someone adds in a function with this sort of bad ordering, or just if we were auditing a code base, we could do that as well. OK, so let's just blow through some other examples. So when we're doing auditing, we've used Semgrep to extract out routes from applications. So for example, let's say there's a specific annotation that says, do this auth check. You can look for anomalies in terms of, oh, this controller is in the admin folder, but it's not requiring an admin permission. That's weird. Or find all the unauthenticated routes. Semgrep makes it pretty easy to prototype this in just a few minutes. We've used that to make visualizations about like these are all the routes in the application. OK, so let's turn it up to 11 and look at some additional features. So obviously, we're fans of regex as any security professional. So you can actually combine regex with other Semgrep pattern features or just use it by itself. So here we're saying find all calls to the AWS Boto 3 client, and then only match those with internal IP addresses. So this would match this, but not that. We also have an escape hatch. So you can actually write Semgrep patterns, match meta variables, like, for example, the bits that you're generating the RSA key with, and then pass it to a Python clause, which basically is arbitrary Python. So here we're just casting this meta variable to an int and then comparing it. So you could do like whatever you want in this, just arbitrary Python. But we do require like a dangerous flag. So like, hey, like bad stuff could happen in this. Sometimes the type matters. So here, we might want to find calls to exec, but only when they're on a runtime object. So in Golang and Java, you can do that with a syntax like this. So that would match these two because they're runtime objects, but it would not match the last one. We can also match JSON. So if you want to analyze like infrastructure as code, you can do that. We recently added a generic mode, which uses some pretty neat program analysis wizardry under the hood to run Semgrep on basically any arbitrary type of text with some limitations. So here, this is us using Semgrep to analyze HTML code, even though we don't actually have an HTML-specific parser. So here we're finding like all script tags and then filtering out script tags that have SRI set. So we would flag this, but not that. Similarly, generic mode can be used to analyze like HCL or Terraform or Docker files or just, again, like any text. So here we're matching any resource with a public read-write. We don't want to be a tool that just gives people more work. Ideally, we want to save people work. So we have support, basically the same syntax you can use for matching patterns. There's also a fixed key. Semgrep rules actually just like compile down to YAML. So you can actually use GitHub's suggestion API to say, don't just flag this, but also give like an auto correct. So here it's like, hey, you're adding a new route, but you're not doing a JWT auth check. So like, please, developer, add this, and they just have to click the button. Or maybe they're using some secret manager, like they're using, say, an environment variable or a config file, and you want them to use Vault for secret management. You could like auto correct that, perhaps. So these are just a couple of examples. The docs have many more rule syntax type things you can do, so feel free to check that out. OK, so let's talk about the ecosystem a little bit. So we so far have looked at writing rules, but ideally, hey, like what do I get out of the box? So we have a GitHub repo that has a bunch of, I think, a little bit over 1,000 now, but it's also, you can just see them live. The reason I am pointing this out is because we actually ported a number of open source security tools like FindSecBugs, GoSec, Bandit, DLint, and others. So you can actually get the same security coverage for all of these tools using just one tool. And there's also been some contributions from the community. Like Damien is a prominent Gopher. He wrote Go Perfbook. He's written a bunch of checks for like, oh, this is weird Go. Node.js scan by Ajin is the preeminent Node.js security scanner, and the engine he used to find things is actually Semgrep rules. So if you go to the Semgrep registry, like if you go to explore on semgrep.dev, you can see a bunch of rules. Maybe you're like, oh, show me all the JWT rules, or I don't know, maybe like React rules, like whatever. Let's see. I think Explorer will have some sort of like highlighted rules. Let's see. So we've also been partnering with OWASP a bit. We're trying to basically take the domain knowledge in various OWASP projects and make them sort of easily accessible and automated. So in your IDE, you're getting feedback. If you want to know, like, do we have the right security controls? Are we following ASVS best practices? We're trying to make that as easy as possible. We also, my colleague Isaac and I gave a talk at this past Global Appsec SF. Basically, like, how do you try to eliminate vulnerability classes by secure defaults and just making sure they're used? So if you think that sounds interesting, feel free to take a look. It's a little bit early stages, but I think we should have some pretty compelling data-driven results in the next year about this, like at real companies, showing that they've been able to eliminate like not just XSS here and there, but like everywhere. So stay tuned for that. If you think Semgrep sounds cool and you want to like integrate it into CI, basically that just means like add this config file into your repo. It takes like a minute or two. But if you use something that's not out of the box supported, it's still pretty easy to integrate. Basically, you can do semgrep-JSON and then pipe it wherever you want. Comes as like a Docker container or Linux binary, so pretty easy to integrate. OK, so let's talk about Semgrep internals. So Semgrep itself, the like core executable is actually two parts. So there's a Semgrep CLI, which is in Python. So this is doing sort of the more user-facing stuff in terms of like parsing command line options, outputting to different formats, whether that's JSON, Serif, or other. The pattern composition, saying like this and that or this or that, that actually happens at this higher level. And to do the fancy program analysis stuff, it calls Semgrep Core. And that's actually written in OCaml. Why? It's because if you're a French person into program analysis, you probably like OCaml. And so PIF, when it was at an Sgrep, when it was at Facebook, the core was in OCaml. So we actually are continuing and pushing to that code base today. So that's why it's in OCaml. And this does the parsing source code, matching rules to source code, and stuff like that. Just to give you a quick flavor of like how the other parts fit together. So if you're using Semgrep in CI, we call that Semgrep Agent, which is basically just a Docker container around Semgrep Core with some additional nice functionality in it, such as being diff aware. Like if you only change 10 lines in one file, like only show the new stuff, and some extra stuff to play nicely with code hosting. So like writing PR comments and stuff like that. We also have a SaaS app where basically if you are hooking, you have like dozens or hundreds of repos and you want to like scan them all continuously, probably you want a single place to set scanning policy. You probably want some like results, trends, metrics, dashboards, generally like enterprise-y stuff. So basically you can have Semgrep Agent hooked up on all your repos and then it reports results here. So everything I've told you so far is basically open source, except for this part. OK, let's get into a bit more detail about how Semgrep works. So at a high level, it works basically exactly the same as every static analysis tool, which is you go from source code, you parse it into some intermediate representation, such as an abstract syntax tree. You then combine that with your security checks in some sort of like pattern matcher or some engine, and you find security bugs, profit. OK, so let's go a little bit deeper. That's like every tool. What's unique about Semgrep? So one thing that's interesting is unlike pretty much every other tool that I know of, the security checks for Semgrep are like basically source code as well. So actually both the rules and the source code go into Semgrep core and are parsed. So there's a grammar for, say, Python, Ruby, Golang, and so forth. And there's some language extensions that allow you to use like meta variables or ellipses in addition to sort of the built-in source code grammar as well. So from that, we go to concrete syntax trees that are more closely aligned to the source code that you originally sort of input. We then convert that to generic syntax trees, which are sort of a language agnostic representation. And then the pattern matching code operates on these generic syntax trees to find security bugs or enforce best practices and stuff like that. So if we were to double click on the parsing code and look at that, I call this out because I think it's interesting and a differentiator in Semgrep's approach. So most static analysis tools, commercial ones, when they say we're going to support a new language, they say like, well, that's going to be like 9 to 12 months and probably multiple people of engineering effort. Actually, since I've joined R2C, we've added like 2 or 3, maybe 4 languages in like 6 months, which is, I think, largely unheard of. And how did we do that? So we actually leveraged this project by GitHub called TreeSitter. TreeSitter and some associated tools are actually used by GitHub for if you're on the site and you do like jump to definition or like the syntax highlighting. A lot of that is actually TreeSitter. So what TreeSitter is it has grammars for like 30 different languages. And generally, these grammars are expressed as a JavaScript domain-specific language. And basically, TreeSitter allows you to go from this JavaScript grammar to generate a C file that you can build and that can parse any code that matches that grammar. And we actually link that into Semgrep core, and then we have like a OCaml shim that converts this C data structures once it parses source code to sort of typed OCaml objects, which are then used to match. So just like some more behind the scenes stuff. So we have like a feature matrix internally for like, for each language, what sort of Semgrep pattern features are supported, because we sort of are tracking as we add support for each thing. We also try to make sure that we don't like do worse over time. Like we don't make changes that make us parse less effectively. So we have like big test sets of examples, say Golang and Ruby, that we continuously run, like say on new builds or once a week, just to make sure things are trending in the right direction. What's interesting here, if we look at the Ruby one, so this last bump, I believe, is actually because we pulled in a newer version of the Ruby TreeSitter grammar, and that actually fixed some parsing bugs that allowed us to get even better parsing coverage. So that's another benefit of using sort of a community project, and we contribute back as well. Obviously, not every language is perfect. Like one that we're recently adding is C#. But what's actually pretty cool about C# is it's actually a community contribution. We are not integrating it. A community member is doing that because they're so motivated. And I think this is probably going to be the first case in the history of a static analysis tool that not the people building the core tool are contributing something as big as language support. Here's a bunch of links. Okay, so we're just wrapping up. I took probably too much time and wrote detailed summaries of a bajillion Appsec Cali talks. So if you're into Appsec and want like a quick sort of summary, feel free to check that out and learn from my pain. I also have a weekly newsletter called TLDRsec, where I, again, do like talk summaries, write like, here's the latest and greatest tools and resources, original research, and things like that. So feel free to check that out as a way to keep on top of things. But yeah, feel free to check out Semgrep. Again, it's free and open source. You can use it on client source code. You can use it on whatever you want. And if you want to look at these slides, you can go there. But yeah, I'd be happy to answer any questions. And thank you very much for your time. And thanks to TrailBits for having me.
Excellent. OK. You can put up your hand and I'll call on you, or you can just blurt it out. OK, William.
I actually have two different questions. The first is about your generic mode. And I'm just sort of curious in general how you've gone about building like pseudo ASTs for inputs that you don't currently understand. This is something that I've thought about a little bit in the context of like automatic pretty printing of arbitrary inputs, but something I'm kind of curious about how you do it.
Yeah, that's a good question. So it actually started as a sort of Hack Week project, and basically one of the program analysis team was like, I really wish we could do this. And sort of the intuition is like, regardless of the file type, there are some things that often imply scope. So for example, like open brace and close brace tends to denote like this scope is inside another scope, or like a white space or indentation and things like that. So basically, it's just like a very generous or permissive parser that sort of keeps scope based on certain identifiers that we believe in general represent like, oh, this is inside that, or this relates to that. And like certain things like alphanumeric is probably like an identifier or like a unit of things, and like quotes usually are used the same way and stuff like that. So yeah, it's basically like one way to parse that when applied just makes certain assumptions about what denotes something that's meaningfully different. Yeah, I can send you more links to it if you want.
Yeah, I'd appreciate that. That's very cool.
Yeah, there are some limitations, right? So you can't do full, like you kind of can do meta variables in the ellipsis operator, but like there are like spanning matches across, say, like hundreds of files can be, or hundreds of lines can be very slow. So there are some like internal limitations in terms of like, well, try to match just locally, because otherwise you might match a lot of things. And so it's not perfect. Obviously, if you're like specifically parsing a language, you can do a ton better. But it does do pretty good in a lot of cases. We've actually used it to parse like Nginx config files and like Docker files and like HTML and like all sorts of things, even though we don't like officially support those. So it like kind of works to a certain extent in a lot of at least base cases.
Cool. And then I had another question. You showed an example of Python where you still detected an aliased import. And I was curious, something that you see a lot in obfuscated Python is you see someone like assign a module object using the equality, using the assignment operator, or they'll assign a function object to another name. Can you catch that too in Semgrep?
That's a good question. Let's try. Yeah, so I think it, yeah, so I know it does like import aliasing, but I'm not sure about, like there are some things obviously with like a dynamically typed language are just like fundamentally hard. Like, you know what I'm talking about.
Yeah, I wouldn't expect to get the inside of an eval, for example, but like, yeah, I'm curious if you did like, say function equals exec instead, right? Or
yeah. So what about?
Yeah.
Yeah, is that what you're talking about?
Yep.
So like we're sort of assigning this to a variable and then calling that.
Yep.
Why are you mad?
I think you want exec.
Oh, yes. Yeah, thank you. Oh, no, I've broken everything. Yeah, so it looks like that doesn't work. Semgrep does do constant propagation to a certain extent. Like one thing you might want to do is like exec, but not if it's hard-coded string, because like you don't control that. So it does do some constant propagation there. Like if you're something like and I think it does work for like local variables a bit as well. So like we are propagating that this is a constant, so we're not flagging here.
That's cool.
So yeah, so it there's certainly limitations. Like if yeah, there's more analyses that we could do that we haven't done yet. One because of not enough time, and the other because of we have constant trade-offs between like how do we keep this super fast, but also like doing more powerful analyses. So that's something that we sort of constantly weigh. But yeah, that's a great question. Thank you.
Thanks for the answers.
Hey, Clint, I had another question.
Hey.
So you mentioned that you prefer false negatives over false positives for user experience and stuff like that. And this might be a bit low level, but I was wondering if you have an example of that actually coming into play and when you implement the analyses. Are there certain analyses that you implemented differently because of this, I guess, approach?
Yeah. So I think I have two answers for you. So one is, so anecdotally in my experience, so I actually interned at Fortify when I was a grad student. And as a consultant, I worked with Fortify and checkmarks and other tools for clients. And I found that in practice, the longer the call chain, the significantly higher it was likely to be a false positive. And the reason is because there's a lot of assumptions you make when you're building an engine about like, basically, like, let's say you have a hash map and like one of the keys is tainted. Do you taint the entire map? If you have like nested objects where you have like foo.bar.baz.whatever, like how precisely do you track the taint in depth? And there's sort of like RAM versus speed and performance versus like accuracy trade-offs that you sort of fundamentally have to make as a tool author. So by focusing on sort of more localized analysis and not necessarily tracking user taint across, say, dozens of files, but really focusing locally, again, like if there's maybe like 3 or 5 hops between files, it is a valid vulnerability. We won't detect that because that's sort of not what we're focusing on. So that would be a false negative. But if something's happening very locally, then like probably it's valid. And I think, let's see, sorry, I was going to say something else. I'm trying to remember. Oh yeah, and then we actually have an internal Mapreduce platform. So basically we can run Semgrep on like thousands or tens of thousands of repos from GitHub like pretty quickly, like tens of minutes. So oftentimes when we were writing rules, we're like, okay, I think this is a good rule, let me see. And then you run it across, say, like 5,000 repos on GitHub, and then you're like, oh, cool, like after you're triaging them, you're like, oh, this seems to be pretty high signal, or like, oh, there's these cases that are not actually vulnerable, or there's lots of false positives. So let me tune the rule to sort of take that into consideration. So that's not publicly available, but for like friends and family security researchers who are wanting to do like bug hunting on a bigger scale, like building that infrastructure is kind of annoying. So if any of you are interested in that, hit me up and I'd be happy to get you access.
Cool, thanks.
Consider yourself hit.
Nice. Yeah. It was basically the shiny toy that I wanted as a consultant. I was like, oh, I would love to do that. And then I was like, cool, I have engineers that have already built it for me.
Cool. All right, what else do folks got?
While people are thinking, another reason about sort of why we focus on this localized analysis is if you think of like, say, a developer or a security engineer doing a code review, like a new pull request comes in and you're looking at the diff. Oftentimes when we are reasoning about the security properties of code, we're sort of doing this in a very localized manner. So we kind of have the opinionated stance that ideally you should be able to reason about security properties of code locally. And if it requires keeping like tons and tons of files and context in your head, then probably there's some like re-architecting or like secure defaults, like secure libraries, infrastructure, tooling that ideally you should build to make it so that you can reason about that locally. For example, like ORMs or other things.
Well, I think we're good. Clint, you gave a really comprehensive presentation, easy to follow, and I think easy to follow up on too. I can see some of the internal chatter at Trailbits that, hey, maybe we should take a second look at this. So good work there. Thanks.
Yeah, we have sort of only alpha support for C, to be honest, and no support for C++. However, we would be happy to help your excellent team if they wanted to make that better. And we're always responsive to bug requests or bugs filed on GitHub.
Great. Okay, well, I think folks know where to find Clint if you want any additional guidance on using this tool or what their company offers. Thank you for the presentation. That concludes Empire Hacking for December for 2020.